So, when does chemistry turn into physics, into particle physics? When you start discussing particle physics, when you learn about particle physics, high energy particles. They are out there, they exist, they are discrete particles from inside the nucleus of an atom. We know from the periodic table we've identified 100 and some odd elements, but we know from 100 years ago there are isotopes of those elements. So those 100 and some odd is actually thousands of elements that exist on our planet and we can measure. So, discrete particle analysis. One of the first things we learned about was the electron, right? The electron sits on the outer, or it sits in shells of an atom. The relationship between the core, the nucleus of the atom, whatever atom it is, defines the number of electrons that hang around it. There is a balance there. And there's also an imbalance there when you get into decay isotopes, elements that decay, that like the carbons, right? There's carbon-12, carbon-14. Those are isotopes of the predominant carbon element that we know and love, carbon-12, carbon-14. So, to measure these particles is a wholly different and discrete area of physics, not chemistry. Chemistry deals with those electrons and those atoms and the binding energies between those atoms. Originally, there was little or no concern about atomic decay of elements until we learned how pervasive they are. Goes back to the banana conversation. What's in a banana? What type of radiation does a banana emit? It's alpha radiation. And apparently it's something we can live with because you don't hear of banana-related cancers. So there's a subtle difference in these energies. That is an alpha emitter that comes from a banana. There's beta emitters. There's gamma emitters. And then there's some that chain, and they emit all of these things within a fraction of a second. They can cascade and release 10, 15, 20 different particles. And yes, they spin electrons and they affect electrons, but they are discrete particles with mass. You get into photons. Photons are an artifact of electron movement, period. What creates a photon is an electron getting pushed into a lower shell or into a higher energy. That transition into the shell actually creates the photon. It is a discrete particle with no mass. Alpha, beta, and gamma particles have mass. So there is a subtle difference. In order to measure these alpha, beta, and gammas, we use high energy particle detection physics. We don't use electron flow, amps, volt, current. These are discrete measurement properties. So when you put these together, you can speak to attributes that they have the same, like a beta particle acting like an electron. It is not an electron. And yet there are similarities you can use in conversation for these things. So let's go back to videos I did on a particle detector, an LND something tube type out there. Its response to alpha particles, to beta particles, and to gamma particles is wholly different. It is engineered, studied, scienced the heck out of how that detector works and sees high energy particles that are not electrons. This didn't undo any of the confusion, but This is something in conversations that seems more predominant these days, trying to minimize subatomic particle energies and the damage and the harm and the long-term persistence in the environment, these man-made things. Yeah, nature made them first, and then we learned about it and exploited it. Why did we stop atomic testing across the globe? Across the globe. Think that was a conspiracy, or that was just friggin' common human sense? I didn't make this any easier. Some people are trying to make it too easy. So there's 6 minutes on high energy particles. Not enough.